Hello dear friends, welcome to Humble Mark Academy. In this video, we shall be looking at the correction of the Cameroon GCE, the Advanced Level Mathematics with Mechanics, Paper 3. We shall be looking at the question 3 of this particular year, guys, June 2023. We shall be looking at the question that is based on momentum, impact, and collision, momentum, impulse, and collision, guys. So friends, stay tuned and watch the video from start to finish because that is the only guarantee you're going to understand every bit of the concept we shall be talking about today. So friends, if you're new to this channel, don't forget to subscribe to the channel because by so doing, you're permitting me to help you to pass your exams, guys. I can only do that once you have subscribed to this channel. Please like the video, friends, and drop a comment in the comment section down below, guys. Let me know where you're watching from. So guys, without further waste of time, let's get started. Okay friends, as you can see, the question reads that two smooth spheres A and B of mass 3m and 2m respectively lie in a straight line on a smooth horizontal floor. A is projected with speed 2u to collide with B, and B in turn strikes the wall. The coefficient of restitution of either impact is 1/4. Find A the speeds of A and B after the first collision. Then B the kinetic energy loss in the first impact. Then there's some small paragraph which says that after B rebounds from the wall, we should show that the speed of sphere A after the second collision is 5u over 16 meters per second squared. Okay, so guys, please pause the video and give it a try, guys. Obviously, please have a writing material by your side so that as we are solving along, you're solving as well. Okay, so friends, let's picture the scenario. Let's picture what is happening. Let's say this is the horizontal floor. Let's say this is sphere A. This is sphere A, guys. Then this is sphere B. Then friends, this is our wall because the question talked about the wall, and the sphere B strikes the wall, right? So the sphere among these two guys that strikes the wall is sphere B, since sphere B is between A and the wall. Okay, now guys, they both have sphere A has a mass of 3m, sphere B has a mass of 2m as the question suggested. Then the question towards that wall, that sphere A was projected with a speed 2u, right, to collide with B, so it must be projected in this direction towards B, and the speed of projection, guys, is given as 2u. Then friends, since it was projected to meet B, it never means that B is at rest, means the speed or the velocity of B in this case is 0 meters per second. Okay, so guys, this is what happens before the collision of A and B. What happens is that after A must have collided with B, right, B acquires some velocity which is going to move in the same direction, hits the wall, then in turn comes backward. So friends, after collision, we expect to see our sphere A of this form. Then friends, it has a mass again of 3m, and it's going to acquire some new velocity which is going to be VA. Then we have our sphere B, which still has a mass of 2m. After collision, guys, acquires another velocity which you can call that VB. Great. So guys, now that we have this scenario set up, then friends, this is our vertical wall. Here is it. Now that we have the scenario set up, guys, all we have to do now is to apply the conservation of linear momentum and the Newton's experimental law of restitution. So guys, conservation of linear momentum is therefore going to give us the mass of sphere A is 3m, its velocity is 2u, plus the mass of the other of sphere B, which is 2, velocity is 0, so everything gives us 0, which has to be the same as the mass of sphere A is 3m, then its final velocity, which you can call that VA, plus the mass of sphere B, which is 2m, plus final velocity, which you can call that VB. If we simplify, you cancel all the m's on both sides and simplify. We're going to have 3VA plus 2VB equal to 6U. We can call this our equation 1. Okay. Now, guys, the Newton's experimental law of restitution simply give us negative E equal to VA minus VB over UA minus UB. Our E is 1/4. Then our VA minus VB over our UA is what? 2U, right? Then our UB, since our B was at rest, means its initial velocity or speed has to be 0. So that's why we have 2U minus 0. Simplifying that, guys, gives us our VA minus VB to be the same like negative 1/2 U. So let's call this our equation 2. Okay. Now, friends, now that we have equation 1 and equation 2, all we have to do now is to solve for the values of VA and VB. Now, guys, to solve for this our unknowns, there are a number of ways in which you can do it, but the easiest way we want to do it is to eliminate, but we are not we don't yet have it in that form where we can eliminate easily. So at this point, guys, if we multiply equation 2 by 2 and we add with equation 1, guys, we are going to see that multiplying here with 2, we are going to have 2VA minus 2VB equal to negative U. This minus 2VB added with 2VB is going to cancel to give us 0. Then the 3VA plus 2VA adds up to give us 5VA, which is the same as here is going to be negative U. Added with this gives us 5U. Dividing all by 5 gives us our VA to be the same like U meters per second. Now, guys, if you substitute our VA into any of this expression, guys, we are going to have our VB to be the same like 3/2U meters per second. Okay. So, guys, these are the speeds of A and B. Okay. Now, guys, now that we have it now, the B part is saying that we should find the kinetic energy lost in the first impact. So, guys, to get the kinetic energy loss, if we are to get the kinetic energy loss, it simply means that initially the spheres had more kinetic energy. Then after the first impact, they lost some kinetic energy. So the kinetic energy loss, guys, which you can call KE loss, is simply given as the kinetic energy initial minus the kinetic energy final. Keep in mind that initially sphere B was at rest, right? Means it had no kinetic energy. Keep in mind that kinetic energy depends on the velocity or the speed. So in this case, its speed is 0, means it has no kinetic energy. So the only initial kinetic energy that we have in this case is that possessed by A. So we are going to have the kinetic energy loss to be the same like that of A is going to be 1/2. The mass of A is 3m. Velocity, speed or velocity of A, which is 2u, all that squared, minus we are going to have 1/2. The mass of sphere A after collision is 3m. Initial final velocity, which is VA we got here to be U meters per second, plus 1/2 that of B, which is 2m. The mass of B, its velocity has to be VB, which is 3/2U squared. So everything, if you simplify that correctly, guys, we are going to have an answer of 9/4 mu squared. Great, guys, great. Then now, friends, the next part is saying that after B rebounces from the wall, we should show that the speed of sphere A after the second collision is 5u/16 meters per second. Okay, so guys, let's picture the scenario. Let's look at how it goes. This is our horizontal floor. This is sphere A, guys, after the first impact with sphere B. After the first impact, guys, it is going to acquire some speed which of VA, right? So this is its speed VA, then VB, then for sphere B we still have its own speed in that direction, which you can call that VB. So guys, this is just the scenario that I just copied here. Then now, guys, what do you notice? Okay, this is our wall. This is a vertical wall. So friends, what happens is that the question towards our that after B rebounds from the wall, we should show that this is the speed of say A. But friends, when B rebounds from the wall, what speed is it going to acquire? Let's see, guys, this is the wall, right? This is B. So when this our B now collides now with our wall, you notice that what when it collides with this wall, it is going to bounce back and be coming in this direction, right? So the speed in which it is going to acquire has to be in this direction. Let's call that VB prime. Okay. Now, guys, to get the value of this speed, because this is the initial speed it's going to have before it makes a second collision. Okay, great. So to get it done, friends, all we have to do is to apply the Newton's experimental law of restitution, which is saying that between the collision of an object and a wall, we are going to have negative e to be the same like v. That's the final velocity of that object as it acquires after collision over the initial velocity. So we're going to have negative 1/4. That's negative e to be the same like the final speed is going to acquire. We've called that our VB prime over the initial speed, which is this one that it was going before it collided with the wall, which is VB. Keep in mind that, friends, our VB is what, guys? What is our VB, friends? Our VB is what we calculated, right? Our VB is 3/2. And since our VB is 3/2, guys, if we make our VB prime the subject, when we substitute 3/2, guys, we're going to have VB prime to be the same as -3/8u. Okay. Now, guys, what then is happening to A after VB, after B must have collided with the wall and it is coming back? You notice that what sphere A is still on its way, right? Sphere A is still on its way in this direction. So now, when they both now make that collision, now when the both of them now collide, all we have to now is to get the speed after the second collision. So they are both going to collide eventually. When they collide now, friends, we can therefore apply our Newton's law of restitution, as well as the conservation of linear momentum. So, guys, let's start with the conservation of linear momentum, which by so doing, guys, we are going to say that the conservation of linear momentum, guys, is therefore going to give us the momentum of A. The mass of A still remains 3m. Its velocity now is now going to what? VA, right? Initial velocity is going to be VA, which has a value of u meters per second, right? Where is it, friends? Wait, guys, here is it, u meters per second. Then, friends, the mass of sphere B is 2m, but the initial velocity of sphere B, guys, is not 0, but it is rather what? It is rather 3/8u, right? This is it, 3/8u. But since sphere B is coming in the opposite direction, it has to take a negative sign. So we are going to have negative 3/8u. That's because the mass of sphere A is 3m. Let's say it's going to have a velocity of x, or a speed of x after collision, then plus 2m, which is the mass of sphere B. It has a velocity of y. Okay, guys, we simplify by counting all the m's on both sides and bringing for the fractions. We are going to have our 3x plus 2y equal to 9/4u. So, friends, if we simplify further, or let's just copy exactly what we have, guys. We're going to have 3x plus 2y equal to 9/4. Okay, so this is what we have, friends. Let's call this our equation 3. Okay, we brought it from here to here. We have equation 3. Now, guys, if we apply the Newton's experimental law of restitution, that is going to give us what, guys? Negative E, which is -1/4, equal to the speed of A minus that of B, which is x minus y over UA minus UB, which is that of UA is what? VA, right? Which is simply U, minus that of B is what? Minus 3/8. So we're going to have minus 3u/8. So simplifying that, guys, gives us our x minus y to be something like -11/32u. Okay, this is what we have, friends. Then now, guys, now that we have this, now all we have to know is to solve for the value of x only, guys. X only, because the question wants to show that the speed of sphere A after collision is 5u/16. You don't need to calculate that of sphere B, okay? Since the question talks only about that of A, so you have to calculate only that for sphere A. So at this point now, guys, for us to be able to solve, if we take 2 times equation 4 and we add that to equation 3, if we multiply equation 4 by 2 and add it to equation 3, guys, we are therefore going to have, if we multiply equation 4 by 2, we're going to have 2x minus 2y equal to 32 times 2 gives us 16. If we add it to this, our guy, we see that y eliminates, right? Then we are going to have 9/4u minus 11/16. So we can multiply top by 4 to have 36, and down by 4 we have 16. So we have 36 minus 11, guys, which gives us 25/16. So we are going to have 5x equals 25/16. If we divide all through by 5, we are going to have our answer x to be something like 5u/16 meters per second, as required, guys, as required. So, guys, that is how we could answer this problem and score all the 13 marks, guys. Keep in mind that each question, as far as maths mechanics is concerned, paper 3 is 13 marks. So we just scored 13 marks, guys. Keep in mind that all these diagrams are not really necessary. They are not really necessary, but they are very, very important as far as the question is concerned, because it enables you to see exactly what is going on in the scenario. Okay, so guys, thank you very much for sticking around to watch the video, guys. Don't forget to subscribe to the channel by clicking on that black subscribe button beneath the video. That goes a long way, friends, to motivate me, and it's going to help you so that each time we have new videos, guys, you're going to see it displayed. When you subscribe, guys, click on where the subscribe tab was so that you're going to turn on your bell icon to get notified so that each time we have new contents, you'll be the first person to get notified. So guys, have a blessed day.